Okay, so let's get started. We're going to be taking a look in this training module at how to program and work with a pulse width modulated style idle control solenoid within our idle control tuning routine using a Link G5 or a G4X system. Now, a pulse width modulated idle control solenoid is one type of solenoid that we can actually work with within our idle tuning. Now, we have a stepper motor and a pulse width modulated motor. Depending on what the OEM manufacturer fit to the engine, that's going to be what you have to tune and to work with. Now, examples of engines that have pulse width modulated style solenoids would be an RB25 engine, RB26, SR engines. So a lot of the older Nissan engines had a pulse width modulated style solenoid. A lot of the Honda engines, K, B, D, F series, H series engines, they all had a form of an idle control motor on them, and they were pulse width modulated controlled. Now, you can usually tell very quickly what the distinction is between a stepper or a pulse width modulated motor. Pulse width modulated are traditionally 2-wire, but sometimes they'll be 3-wire for looking at the actual connector on the solenoid as you plug it in. A stepper motor is traditionally 4 to 6-wire, so depending on what type you're controlling and working with. So that's one easy distinction if you're looking at it. And let's say you don't know if you have a stepper motor or pulse width modulated. That's an easy indication just looking at the connector plug, how many wires it has going into the actual connector that you plug into that solenoid. So what we'll find is the difference between the two is that a pulse width modulated solenoid is duty cycle controlled. We're going to be pulsing it at a certain duty cycle and a certain frequency to open a valve a certain amount. Essentially, what we're having is a controlled vacuum leak. We're bypassing a certain amount of airflow from the throttle plate and allowing that additional airflow to come into the engine. We're essentially controlling the airflow, which controls the engine torque to allow frictional losses, let's say on a cold start, or we can counteract, let's say, air conditioning turning on. It gives us the ability to add a little bit more engine torque in situations where we would have stalling occur if we didn't allow more airflow into the engine. So, very useful for programming. And when we're talking about working with a stepper motor, which we're going to cover in a separate training module, actually the next training module, the stepper motors are built internally differently. They're going to find that there has screw type of mechanism in them. And each time the screw turns, it's going to count as a step. And if you find, let's say you have a total of 200 steps or the range it can move in, at 200 steps, that's the maximum airflow. At 0 steps, that's minimal airflow. So it's just a different strategy in terms of what we program for the length. That's why we're going to have 2 different tutorials talking about stepper motors versus pulse width modulated motors. So some engines that come with a stepper motor are going to be 1J, 2J, Z engines, Mitsubishi 4G63 engines. They're all fitted with a stepper motor. Stepper motors in general are more problematic for control compared to a pulse width modulated. Pulse width modulated is much simpler to get working correctly and consistently. That's the big difference there about being consistent with the idle control compared to a stepper. So when the OEM manufacturer fits the engine with a pulse width modulated or a stepper, you can switch it over, you can convert it and change it, but typically we stick with what the manufacturer has put onto the engine. The other best option is to switch it to drive-by-wire. That eliminates all the kind of oddities that can go on with idle control programming with an idle control solenoid. But we're going to talk about drive-by-wire idle tuning and drive-by-wire control later in the training course. You can always retrofit any engine to drive-by-wire, which is definitely my go-to when I have my choice. If I'm trying to plan out a project of what I want to put onto the engine, drive-by-wire is definitely the best option to go with for overall control and idle control. Okay, so now that we've talked about some of our differences here between pulse width modulated and stepper, let's jump in here and talk about some of our programming details for working in this control. So we're going to move from our basics page and we're going to jump across here into our idle page. Now in here, we have all the programming and all the details in order to get our idle control sorted out with a pulse width modulated solenoid. Now there are going to be some basic configuration details that we need to set up for a pulse width modulated solenoid. So first thing we're going to do is go to our mode and we're going to go from off and we're going to click this to either open or close loop. Now you can work an open loop. Essentially what it's going to say is that Link is not going to take a look at what your actual engine speed is and compare it to a desired target speed for idle and then make adjustments to what it's sending in terms of a pulse width, in terms of a duty cycle control to the idle control solenoid. So essentially what you place into what's known here as your base position table, that's how much duty cycle it's going to command to the solenoid, and it's never going to change that. Open loop has its place But I find that closed loop is actually more effective, and you can get your base position table here, your feed forward table, dialed in much quicker using the closed loop control. So we're going to talk about this here in terms of closed loop control right from the beginning. You can always put it in open loop if you want to make things a little bit more simplistic, but realistically, working in closed loop here gives us a lot of benefits, and I'll demonstrate that here in this tutorial. So we're going to grab closed loop as our option. Now it's going to ask, do you want to clear out the idle target table? We'll say yes. Do you want to clear out the idle base position table? We'll say yes. We see two of these tables here populate. One thing that we need to note right off the bat here is that the idle target RPM table, we can see it's set here for idle base position. This is actually incorrect. I've noticed this before when I turn on the closed loop. We actually want to go ahead and unlock this. And then we want to go over here to ECU settings, and we'll go down in here to, let's find our idle control. Oh, I see our idle speed control. And we want to go to our idle target RPM table. Now we see the idle target RPM here is what's populated in this window. For whatever reason, it puts the base position in both windows. We actually have to have the target we want to run our engine at. That's going to be where it can make its evaluation and what it needs to adjust to our base position table. So we'll talk about these two tables here in a little bit, but just to make sure you have your idle target table appearing here and your idle base position table appearing here in this window. Now the next thing is we need to assign our actuator type. So at this point, Link doesn't know if we're controlling a stepper motor or if we're controlling a pulse width modulated motor. So we need to call that out right here. If we go to our actuator type, we can have none, which means that we're in not controlling any idle control motor. We can go solenoid, that's pulse width modulated. Stepper, obviously, is a stepper motor. A 3-wire solenoid operates similar to an actual pulse width modulated solenoid, but it's a 3-wire design. That's some unique situation. Some Toyotas have that for a 3-wire solenoid. There's actually other engines, but Toyota 2ZZ engine, I believe, has a 3-wire solenoid on it. Okay, so what we're going to be selecting here is a solenoid that's pulse width modulated for the option here, so we'll click OK. Now we have our voltage compensation that we have to decide if we want to turn it on or off. For right now, I'm going to leave it off just to keep this in a simplistic routine. I haven't really found a need to put the voltage compensation on. What this is going to do is as the voltage fluctuates or changes, it's going to try to compensate in the background for that in the idle control routine. This can complicate things, so I'm going to leave it off for right now. I think 99.9% of the time I leave this off. I haven't really found a need to turn it on. Now there's the output. This is where we need to...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.